Hello, welcome back. All right, so still on Kirchhoff's law. Okay, so I have another example here. So we are to use Kirchhoff's law to solve this network. Now, this is a bridge network. Okay, so invariably we are being asked to find the current and the voltage drop across each of these resistors. Okay, so now let's analyze it. The very first step in applying Kirchhoff to a network is to start with use Kcl to label the current across each of the resistors and across each of the components. Okay, now you know very well that current actually flows, then it reaches this junction, it will divide. Okay, so now let me call the current that actually divide and pass, the one that passes through the branch of 2 ohm resistor to be I1, then this to be I2. Okay, so now this two current is moving away from this junction, so their sum is equal to the current that is entering the junction. Okay, so that's going to be the current from this main branch is I1 plus I2. All right, now we still proceed. We still have more junction, right? There's still a junction here and there's still a junction here, right? So now I2 actually reaches this junction, then it branches. Okay, some will pass through the 2 ohm resistor, some will pass through the 4 ohm resistor. Okay, so now we have the current I2 entering into the junction, this junction, let me call this junction B. Okay, now then we'll now have there are two currents leaving the junction. So invariably, since already this I2 is entering the junction, okay, I can use I3 to represent the one that is branching through this 4 ohm resistor. So remember, according to Kirchhoff's, the sum of the current entering the junction is equal to the sum that is leaving the junction. Okay, so I2 is the sum of the current, and part of it is actually entering, is passing through the 4 ohm resistor. So the remainder, remember the remainder, we actually pass through this 2 ohm resistor. I2 is the sum. Okay, so I2 is equal to I3, then plus the current that is actually that will be passing through this 2 ohm resistor. I can call it X. Okay, so to get this, the current passing through the 2 ohm resistor, it will definitely be I2 minus I3. Okay, so let's label it. So the current passing through this 2 ohm resistor is I2 minus I3. All right, so I still have one more resistor to label, one more resistor. Okay, so let me go through this part. Now I'm having I1 passing through this 2 ohm resistor, and it's going to come to this junction. Okay, let's say this just this junction here is A, B, C. Okay, let me call this junction D. All right, so I1 is actually coming towards the junction D, and I3 too, as it passes through this 4 ohm resistor, will still meet at this junction. Then once they meet at the junction, they will combine, okay, and move away. So I3 and I1 is moving towards junction A, and the current that is actually going to be, that is passing through this 3 ohm resistor, okay, is moving away from the junction. Don't forget Kirchhoff's law. Sum of current entering through the junction is equal to sum leaving the junction. So that means to label this for this 3 ohm resistor, that's going to be the sum of I1 plus I3. Okay, so we are done labeling. All right, since we are done labeling, now let's number 2, let's apply KVL for the loop. Okay, now depending on the number of variables that we have, okay, we are going to consider the same number of loop. I have 3 variables. I have 3 variables for the current I1, I2, and I3. So we simply means that I will need to apply KVL for 3 loop. Okay, I will just look for 3 loop. So you can choose any loop, you can decide to choose any loop. Okay, Of course, you know that this is a loop. This is also a loop. Okay. And the entire network is a loop. Okay. So I can go by, let's label everything so that I will tell you the loop I'm considering. Okay. So let's say this is, I can call this point E and I can call this point F. Okay. So let's say I want to go out through the loop of okay, starting with loop E. Okay, pass through F, then I'll go through A, through C, then return back to E. So that is a loop. Okay, so I want to apply KVL to that loop. So applying KVL to the loop, of course, you know very well that I'm going from negative to positive for the source voltage. That's going to be plus 10 volts. All right, then I'm going through A. Remember, I have to, I'm only going in a straight line. Okay, I can now encounter, I'll just go to, up in that clockwise direction. So since I have recorded this, I'm going to pass through the, okay, this 2 ohm resistor. Is it 2 ohm or 1 ohm? Okay, it should be 1 ohm. 1 ohm resistor, okay, that has I2 passing through it. And you know very well that since I'm going that way, this terminal is plus and this other terminal is minus. From plus to minus, that's a drop in voltage. So it's gonna be minus 1 times I2. That's still gonna be I2. Okay, so I'm still going in a straight line. This time now I'm passing through this 2 ohm resistor, having the current I2 minus I3, and the same thing happens here. The very first terminal is plus, the second is minus. All right, since I'm moving from the positive. Okay, all right, and let's get that voltage, and of course that's a drop in voltage. That's going to be 2 times the current I2 minus I3. Okay, and here we go. So as I now go, remember I'm coming all the way. The path is E, F, A, C, then back to E. So I'm coming all the way back to E. We are started from. Okay, so I hope everything is all covered. So this is for loop one. This is gonna be equation one. So don't forget that everything according to KVL, everything is equal to 0. So now let me simplify. Open the bracket. This is gonna be minus 2I2 minus 2 times minus I3. That's gonna be plus 2I3. Okay, is equal to 0. So let's collect lightens together. You know what I normally do? I will want to collect the variables. Okay, I wish to collect the variables to one side of the equation. Okay, I wish to collect the variables to one side of the equation. So I'm going to move I2 to the other side of the equation, becomes plus I2. Move this to the other side. After I must have added, okay, let me add the I2. Minus 1 I2 minus 2 I2, that's 3 I2. So I move it over, that's going to be plus 3 I2. Then if I move plus 2 I3 to the other side, it becomes minus 3 I3. So since I'm not moving 10, so it still remains 10 volt. So that's is equation 1. Okay, so I have to look for another loop. Okay, so this time around now I can still consider, let me consider the loop of I want to consider loop A, B, D, then back to A. AB, D, then A. Okay, so let's flow. So since I've already labeled it, okay, this is starting with um 1 ohm resistor. Okay, that's plus to minus a drop in voltage. That's 1 times I2, which is gonna be minus I2. Okay, so here and now I'm passing through. I'm gonna pass through the 4 ohm resistor I3. Okay, so of course the same thing happens here. I'm going, that's going to be plus minus in the direction of the current, plus minus. Okay, so if that is plus minus, that's gonna give me still negative. So negative, I'm gonna have negative 4I3. Okay, so still I'm now going to be passing through this 2 ohm resistor. Now if I'm passing through this, I'm going to go against the current. Remember, okay, going through the current, this is positive and this is negative, right? So I'm going against the current that is already um, in this direction. So now it simply means that I'm moving from negative to positive, which is a rise in the potentials. Okay, so and the current across these 2 ohm is I1, so that's going to be plus 2I1, plus 2I1. Okay, is equal to 0. Okay, so let's rearrange. So I'm having plus 2I1 minus I2 minus 4I3 equal to 0. So I'll call this equation 2. I need one more equation, so I will have to take one more loop. Okay, so and now let me look at under loop. This time I'm looking at B, C, D back to A. Loop D, C, B, D, C. Okay, I'm starting with B. Please pardon me. Okay, so I'm starting with B. B, starting from B through C, D, then back to B. Through C, D, back to B. Okay, so let's look at that flow from positive to negative. That's 2 minus 2I2 minus I3. Minus 2 bracket open I2 minus I3 close bracket. Now I'm going to go through this. Okay, now I'm going remember the current is flowing in this direction. Okay, so I'm going in opposite from where the current is flowing. Okay, in this direction. Remember, this is going to be plus, this is going to be minus. Okay, the very first point where the current meets is plus, the second point is the second terminal is minus. So I'm going opposite direction. That's going from negative to positive. That's going to give me positive voltage, and that's going to be 3 plus 3 into I1 plus I2 I3. Okay, still flowing this from this way negative to positive. That's I3 plus 4 I3. Okay, plus 4 I3, so equal to 0. So let's open up. Minus 2I2 plus 2I3 plus 3I1. Okay, plus 3 I3 plus 4I3 is equal to 0. Okay, here we go. Collecting like terms. Okay, 3I1 doesn't have any like term. Okay, so minus 2I2, still there's no like term. Okay, okay, then 2I3 plus 3I3 plus 4I3. That's 5, that's going to be 7I3 plus 7I3 is equal to 0. So this is equation 3. So I've actually completed my 3 equations. Okay, so let me write them out. Starting with the first equation. Equation 1, 3I2 minus 2I3 is equals to 0. Okay, okay, 3I2, am I correct? Yeah, 3I2 is equal to 0. Equation 1. Okay, equation 2. Equation 2, 2I1. Equation 2, I'm having 2I1 minus I2, okay, minus 4I3 equal to 0. Oh, the first equation is equal to 10, please pardon me, not equal to 0. Okay, then the last but not the least equation, I have 2I1, 3I1, please pardon me. Okay, 3I1, 2I2 plus 7I3 is equal to 0. Equation 3. Okay, so how do we solve this equation now? This is not just a simple simultaneous equation with two variables. Okay, this is a system of equation that has three variables. I know very well that the method we used previously, okay, the method of substitution can it will work here, but it will be so tedious. Okay, it is not advisable to use those methods. So I'm going to teach you the determinant method of solving. Okay, determinant method of solving system of equation. System of linear equation. Now, the reason why you should learn the determinant method of solving system of linear equation for Kirchhoff's law is this. Okay, the variables depending on the complexity of the circuit might be so many. Okay, there are some circuits that will require you to solve for more than four variables, four currents. Okay, so a situation, if you encounter such situation, you need a more, um, let's say, easier way of solving such equation. So now I'm gonna introduce matrix and determinant method of solving this. Okay, it's called Cramer's rule. So now, first, I'm going to write the characteristic matrix of this equation. What is the characteristic matrix of this equation? I'm going to separate the coefficient of the variable, okay, and the variable from two into two matrices, okay, into two rectangular matrices. So let me separate the coefficient. Now the coefficient is in order. I have three variables, I1, I2, and I3, okay. So it's in order. So the coefficient of I1 in equation 1 is equation 1 doesn't have I1, so the coefficient of I1 is 0. So I'll just write 0. But the coefficient of I2 is 3, so I'll put it here. The coefficient of I3 is -2. I'll write it. Okay, so for the equation 2, I'm having 2 minus 1 minus 4. Equation 3, 3 minus 2, then 7. Okay, so this is for the coefficient. Then I now have to separate the variables into a column matrix. Okay, also arrange in order. I have the variable goes I1, I2, and I3. Okay, it's equal to the constant at the right hand side of the equation, which is 10, 0, 0. Okay, so this is the characteristics matrix. That's the matrix form of this equation. So how do we now use determinant to solve this particular, to solve for I1, I2, and I3? Okay, now if you want to solve for I1, you are going to uh you're going to divide the determinant of the coefficient, okay, of the variables, but replacing the coefficient of I1 with the constant value. Remember the first column here, okay, actually shows the coefficient of I1, right? The first column is the coefficient of I1, second column is the coefficient of I2, and the third column is the coefficient of I3. So I'm going to write the determinant of this entire uh, matrix, okay? But I'm only going to replace this coefficient of I1, since I'm looking for I1, by the constant value. So the constant matrix, okay, which of course is 10, 0, 0. Then I will write others, okay, the way it is. Then I have to divide it by the determinant of the entire coefficient, okay, determinant of everything, this the way it is actually written. So that 0, 2, 3, okay, 3 minus 1 minus 2 minus 2, 4, then 7. Okay, so I believe you know how to solve this determinant, 3 by 3 determinant. Okay, I believe that you know how to solve that. All right, so let's solve it. Of course, you know, the only way we'll solve it is we're going to separate this 3 by 3 determinant into 3 2 by 2 determinants. Okay, by separating, I'm going to separate them using the values of the first row. What am I going to do? I'm going to take out 10, then multiply it by its minor. What is the minor of 10? The minor of 10 is the determinant I get after I cross the row that belongs to 10, then I cross the column. So what I have left is the minor of 10. So what do I have left? That's -1. Okay, let me clean up. Okay, so what do I have? So what do I have left? So I have -1 -4 minus 2, then 7. Okay, so we go to the next. The next is 3. Please, for 3, okay. Uh, 3 will be minus, the middle will be minus because it goes this way: positive, negative, positive. That's how it goes. So 3 now, I still need to multiply by its minor, the minor of 3. Okay, so let me clean this up. All right, so how do I get the minor of 3? Simply, we have to cross the rows. Okay, that 3 belongs to cross the columns. Then what I have becomes the minor for 3. So that's going to be 2, 4, 3, and 7. Okay, so plus, let's now go for the one of minus 2. Okay, so it's already minus 2. So we'll have to write the minor of minus 2. Of course, the minor of minus 2, if I should cross the column of minus 2 and the row, I have 2 minus 1. Okay, then no, I just made a very big mistake. Okay, I made a mistake. Okay, okay, this is I'm considering the numerator. So this minus 3, the minor is supposed to be. I'm working on the numerator. Please pardon me. Okay, this is what I'm doing here is just is for this is for the numerator. All right. So okay, that's gonna be for minus 3 0 minus 407. So that's supposed to be 0 0 here. Okay. So for minus 2, that I have, that's 0 minus 1, then 0 7. Okay, I believe that this one right here is correct. Okay, that's for the that's for the numerator. So I will do the same for the denominator. Okay, for the denominator, okay, this is gonna be 0 multiplied by its minor. So that's gonna be minus 1, 4, minus 2, 7. Okay, so the next is minus 3 multiplied by its minor. Of course, the minor will be 2, 4, 3, 7. Then the last but not the least, plus minus 2, okay, into its minor, 2 minus 1, 3 minus 2. Okay, so let's see how that works out. So this is going to be I1 equal to, of course, you know how we work on the 2 by 2 determinants. So you multiply diagonally. 7 times minus 1, that gives me minus 7. Then minus 2 times minus 3. Okay, it's going to be minus into minus 2 times minus 2 times minus 4. Please pardon me, that's plus 8. That's going to be 8. Okay, close this bracket, go to this. Okay, here we go. Minus 3, bracket open. This time this is 0, is gone, and this also times this is 0, so everything is 0. All right, then plus times minus is minus. So let me just write the minus at once. Okay. Okay, so I will write minus. Okay, so that's gonna be minus 2. Minus 2 times 2. All right, that's gonna be minus 4. minus into minus 3 times minus 1, that's gonna be minus 3. Okay, so to the denominator, now this will give 0. Why? Because after solving this, if I multiply by 0, it still give me 0. So this is already 0. This is gonna be minus 3 into 2 times 7 14, and minus 3 times 4 is 12. Okay, here we go. Minus 2 bracket open, this is minus 4, then minus into, oh, for myself still making this mistake of, okay, of confusing the denominator with the numerator. Please pardon me, this is still gonna be 0. Okay, this will still be 0. This is for the numerator. So it is in the denominator now. I'll have minus 2, this minus 4. Okay, 3 times minus 1 is minus 3. Okay, so let's proceed. This is 0, this is 0, they are gone. So I'm left with this. It's going to be turned into minus 7 minus 8. Okay, that should be minus 15. Divided into, okay, so here I have 14 minus 12, this 2, 2 times minus 2 times minus 6, minus 2 times minus 3, that's going to be minus 6. Let's work on this. This is plus minus 4 plus 3, that's minus 1. Minus 1, okay, multiply by minus 2, that's going to be plus 2. So here we go. 10 times minus 15, that's going to be minus 150 all over minus 4. Okay, so I think you can do that division. Let's do that. 4 into 15. Okay, how many do we have? 4 into 15, that's 3 whole number. Then carry 2. Okay, let's carry 3 to 30. And 4 goes into 30. I believe I will have 7, right? 7 whole number. Then 2 all over 4. Ampere. Okay, I'm pretty sure that um, this is um, this have been simplified for you. Okay, I believe that by the time you take your time, it's actually long, but practice, okay, consistent practice will actually make you perfect. So we are going to actually look at, I'm going to give you the opportunity of, okay, using the same method to find I2 and I3. Okay, then in the next video I will actually do the correction to that, and we'll look at more questions. All right, so see you in the next video. Thank you very much.